it's a real one-off, Goole Swing Bridge. It's one of the only one in the country of this kind of design and make, and it's certainly been very much a one-off when it comes to the project in itself. It was actually one of my first site visits back when I joined Network Rail 15 years ago. We're going out with a chap called Tony Carrick, who some people in this room may know. And so, yeah, it's certainly been a project that's been in the offering for a long time. But over the last 2.5 years, we've really kind of brought it into play and really done what needed to be done to ensure this real piece of heritage continues to be utilised and run the railway in the right manner. So, next slide. There we go. So, Goole Swing Bridge, a 160-year-old work of art, as it's been described by Scott Robson, who's part of our and heads up our maintenance team based in Doncaster. And our programme engineer manager, David Cook, has recently said to me, one of the most isolated and exclusive museums in the UK. It really is, and that's what makes it a really fascinating piece of infrastructure to work on. I've certainly been very proud to work on this as a project. As you can see from some of the pictures that are on the screen there, I've really been working with very old, antique, heritage type infrastructure. And due to the heritage nature of it and the planning consents around that, we were driven down the route, quite rightly, to actually refurbish rather than just replace with modern equivalents. Obviously, that comes with its own issues as we move through the project. But Rob and John, I'm sure, will come on to them elements. But what I wanted to do was we've got a great video about Goole Swing Bridge that was produced a couple of years back now. So before we were kind of on site. But it really gives, the video hopefully gives you a bit of a more how the bridge and the operational equipment within the bridge works, and also a little bit more about the history. John, I'll hand over to you just to sort that out for us.
This is Goole Bridge, 160-plus-year-old work of art.
There's a real beauty to the infrastructure we have, created by great engineers like Brunel, Stevenson, Harrison, Locke, pioneers of the system.
You could say this is a bridge that requires swinging for vessels and the passage of trains, but it's so much more than that.
One of the finest examples of swing bridges ever built. The history of Goole Swing Bridge kind of goes back to about the 1840s, where there were various plans put in place to build a connection between the South Yorkshire coalfields and the Port of Hull. Because of the different railway companies, nothing really happened until about the 1860s, when the North Eastern Railway put forward their plans for the Hull and Doncaster branch. The River Ouse was a highly navigable channel, so there was a lot of big ships going up and down that river. So it wouldn't have been appropriate to put in a normal bridge. The swing bridge was designed by Thomas Elliot Harrison, and it was opened in 1869.
Diesel engine powers a 3-throw diesel vertical pump that then creates oil pressure, which provides the pressure for an accumulator, which is just a large mass. The pressure lifts the accumulator up, and then it's that accumulator level, the pressure, that can provide a slow release and steady flow of pressure for the operation of the bridge. On the side of the structure, there's a board that has various levels of height, 4, 5 metre, etc. Everyone has to be in contact with the harbour master at first, and then obviously the bridge operators, to determine whether they have enough air draft or clearance to get underneath the bridge. And if they don't, obviously then the bridge needs to be swung. There are only 2 pilots, as they call them, that are allowed to negotiate this channel. A vessel will pull up at a place called Blacktoft. The pilot will then take charge of the boat and negotiate through the bridge, and then it gets to Howden Dyke, where it's returned back to the original captain. You have to be specially trained to negotiate through this channel. It's finding that balancing act between keeping the railway running, keeping the heritage side of things correct, and I think that's what the impending upgrades will address.
The signal cabin on top of the bridge is pretty much original, so that makes it one of the oldest signal cabins on the network today.
There's 3 indication systems upstairs that will all become one. What is a series of levers will be a start and stop electronic PLC controlled system. The exterior will look exactly the same, it'll just change inside.
Although it's a heritage structure and it's over 150 years old, it's still doing its job today, and that's down to the care and maintenance we give to the bridge. It kind of really demonstrates to others how we care and what we value about our network.
I'm proud to be working on something so old and so unique.
They stand as a testament not only to the engineers who built them originally, but perhaps as inspiration for future engineers.
If you feel that engineering is the way you're going to go, there would be no better place than to experience this in all its glory.
These structures are a part of the community they're in as well. You know, they become part of that collective memory and they belong to the area. So we do have a duty of care to look after these things and celebrate them for what they are, which is an amazing engineering achievement that still does its job today.
Get the presentation back on. Okay, so in terms of tonight's meeting, we just
At
wanted to...
Curry's, we're doing everything we can to help you save energy.
Because when you save energy, you save money too. To the tills.
Saving energy, baby.
I'm glad it was just an advert and nothing else. That's all I can say.
There we go. Apologies.
That's why I wasn't doing that element of it. Okay, so tonight, we just wanted to give you a flavour and hopefully of the project that we've been doing. And we're going to go through, we'll talk through the delivery team and who's been involved. A bit of a project overview, so why the need for this renewal. This is a £10 million investment from Network Rail. Scope of the works, the access, the challenges, which are numerous from an engineering point of view, which Rob is going to really guide us through. The current project status, where we're currently at, and then delve a little bit deeper into them engineering challenges with principal elements around the refurbishment of the engines and also integrating that new and that old technology into one. Okay. So it's a little bit about the delivery team. So in terms of Network Rail, myself as senior portfolio manager and John as lead portfolio manager, and then we've had David and Tony involved as well. Our principal contractor and the real kind of guiding minds behind this project has absolutely been Amco Giffen, along with Fairfield Control Systems and Ipswich Hydraulics. So Rob has very much been leading it from an Amco point of view, along with Tim and Rob Greenwell. But it's really been a massive team effort, and certainly Ipswich Hydraulics and Fairfield, along with Amco, really had to scratch their heads around a lot of the engineering requirements around this project, unearthing stuff, looking at engines that haven't been touched and refurbished for many, many years. We've had there's 2 engines in this bridge, but only one of them has actually been in action for the last 20 years. So that kind of gives you a guide as to why we've been needing to undertake this work. So why the need for the renewals? So delays to our passengers' journeys. The bridge has constantly failed over numerous years. Primarily in the summer months, in the hotter months, is where we've seen the most failures. And that's led to no bridge swings without network rail maintenance being on site. So the signallers would refuse to do bridge swings unless that maintenance attendance was there, because we were getting to a point of where maintenance were having to go in and literally use kind of a car jack to jack this bridge up because it was failing. There's numerous elements failing. So, you know, that high dependency there of that maintenance attendance takes them away from other incidents, other works. And, you know, costs were in the region of probably £200,000 a year just for maintenance call outs, just for this piece of infrastructure alone. I mentioned just slightly earlier on about the 20-year dependency on only one engine. If that one engine failed, the other engine was completely out of action. So there was no kind of backup there. And it was a matter of maintenance, you know, tinkering, oiling, and getting them engines back into play as soon as possible. That one engine that they had to play with, so no spare parts. This is very, very old equipment that they're dealing with. Well, also, one of the other key requirements is to make sure that we keep this bridge where we need to open for river traffic. The river has precedence over railway traffic, so it's Network Rail's responsibility to ensure that we are in a position when a boat does want to come through, and it is quite a you know, there's an area where we get quite large vessels coming through that area, delivering goods, from Goole docks, etc. You know, it's absolutely key that we make sure we don't delay the river traffic in line, obviously, with railway journeys as well. So that's just a little bit of a flavour of why we would need to do the renewals. And I'm going to hand over to John, who's been our lead portfolio manager on this. John was on site for 4 weeks last June when we had a 4-week blockade to deliver this project. So I'm going to hand over to John, who's going to talk us through a little bit more about the scope of the projects.
Thanks, Jebs. Evening, everybody. So yeah, 4 weeks in June, it was quite good. It's nothing compared to what these guys have done. They've lived and breathed it for the last 18 months on site, and all of what we've gone through here and what we're talking about tonight wouldn't have been possible without the amount of effort that these guys have put into the project. But as far as what we're talking about, as far as what the scope was for the renewal, so one of the first things was to install a new hydraulic power unit, because the accumulator that we saw earlier in the film, that is actually a second-hand one that came out of Hull docks around about 1900. The original one in the centre of the bridge failed, I think, 7-8 years, something like that, after the bridge had been initially installed. So they took one out of Hull docks. So that is second-hand and still at least 130 years old, plus however long it had been in Hull docks. So we needed to put in a new HPU, which on the screen, I don't know if it shows up on here. No, it doesn't. Oh, just see my mouse. The top left picture is the new HPU, which has been installed on the bridge. A new control system. So obviously, with the new equipment, we need a way of operating it. Now, as it was said in the video, it would be replaced with a new push button stop start. That was before we came across some of the issues, which we'll talk about later on, which was to do with heritage, and we had to retain some of the original control systems. So we have put in a new control panel that is now in the signaller's box on top of the bridge. I believe it does have the capability, if we wanted it to program it, so it would do press one button and it will just stop, start and everything automatic. But because of the heritage requirements, they still drive the bridge. So there's still the old brass wheel in the middle of the room where you turn it left and right to swing the bridge left and right. There's still the levers that interlock with the signalling system and release the signalling and allow the bridge to operate. So it's kind of a hybrid. It's become more of a sympathetic renewal rather than a wholesale renew everything. The 2 turning engines, so we saw those in the video earlier. There's more slides on them later on, and Rob will talk some more detail about what was involved in those. But the 2 3-throw turning engines that just basically provide the power through the gearbox to actually rotate the bridge. I mean, the structure itself is 80 metres long, I believe. The centre span it's a hell of a bit of kit, you know, a lot of weight, and so you can imagine the power and the torque that's needed of those to be able to get that rotated, and it goes silently. Once you've got it moving, it just push it. jacking system, rest blocks and cylinders and tapered wedge bolts. Again, all part of the all hydraulically operated. The original jacking system was based on a scissor jack type of arrangement. So it was a central thing pushing and then two things coming down on either end to raise the end of the bridge, which needs to be lifted up, could remove the rest blocks, which the bridge sits on, and then the bridge hangs, then it can rotate. Those original jacks didn't provide even pressure, so the bridge didn't lift equally. And over the years, different things have been added to the bridge, different works have been on, so the bridge itself was unbalanced and twisted. So part of the issue was when it swings back, when it's got hot, when it's been swung and the bridge expands, it wouldn't clear the blocks to be able to go back into place. So that's when they had to use the bottle jacks to lift the bridge manually to get it into place. So the picture up here is some of the hydraulic pipework that's been put in as part of the renewal. So the main feed comes down the bridge and then up to a manifold here, and then various pipes to all the different jacks and rams at the end of the bridge. All that was manufactured on site during June last year in some of the hottest weather we've ever had. And it's a fantastic thing to see. There's probably some more photos, there's many more photos around, but it's an absolute work of art, just the pipework that they've put in as part and parcel of the renewal. Where we're up to. A new shore-based DNO supply and backup generator. So the big green box in the bottom left-hand corner is where we get the main supply in, and then we've got a backup generator, UPS, control, and everything like that to send the power across to the bridge. Originally, it came under river crossing. There was a cable across to the centre of the bridge, backup generator on the centre of the bridge, and some switchgear. Several issues with that. One was when there was a big flood about 10 years ago, 12 years ago, something like that. The main incoming switch was actually under the water level. So that was always part of the renewal to lift that out of the way. But also refueling the generators, it meant 25-gallon cans of oil had to be lifted onto the bridge manually. The only way onto the bridge is walking down the 4-foot, so walking down the track through a series of very small doorways, very precarious steps. It was a health and safety nightmare. So by moving it to the shore, it's much better for maintenance. It can be refueled. It can be accessed at any point in time. If the bridge was to fail open, you can still get to that. Whereas before, and if the bridge had failed in the open position or open to river, you couldn't get on it unless you jumped or swam or got a helicopter. And then, as I said, 2 new under river crossings to get new cables and services across to the bridge from the shore. So that was done via directional drilling. I think you had some fun and games with that as well because of the depth that it went to. The senders couldn't actually find the end of the drill, so it was people in boats looking out for it, and all sorts of fun and games to get the 2 new tunnels through, so then we could pass all the new pipework and the new power cables through to the centre of the bridge. Moving on, should be. So we have also replaced all the power and domestic services to the jetties, to the centre, the east and west jetty. The east jetty, we've only been able to put power up to it and leave it as a junction box because it's currently condemned and it needs some civils work to be able to go on the deck. So if we'd put stuff up, it would have been ripped out anyway when they go to do the additional work. But got all the new domestic supplies to it. We've installed an IGUS chain, which is a brand name. IGUS is a brand. It's basically we haven't got a photo of it, unfortunately.
Similar to a crane.
It's basically a movable link between the fixed jetty and the movable part of the bridge, and it carries all the services, all the hydraulic oil, all the cables through a chain that looks back on itself, so it can fold and move and provide constant supply to the movable part from the fixed part of the bridge. Signalling works. So we had to. Originally, we was going to replace everything now with all fancy push button, but because of the heritage requirements, having to use the original levers, so we've had to install an interlocking between the existing levers and the new control system. So some clever switches, lots of cabling. We had right at the last minute. We had an issue. one of the signalling cables failed 2 days before we were due to hand back the blockade. So we had a 30-day blockade last year. It was something not to do. It wasn't anything to do with the job, but it just happened to be a cable failure whilst we was on site. These guys managed to get people in, get it fixed and get it commissioned and hand back the possession on time, which was absolutely fantastic. Had to relocate detection centre nose bolts. I think the centre nose bolt's now out of use, isn't it?
Yeah.
So that's out of the way. But the tapered nose bolts, one on diagonally opposite corners of the bridge, and they fire in, and they basically, I think it's about 4 or 5 inches leeway that gives you to get the bridge drives into closed position. The bolt fires in, will pull it back into that last final bit, and then the signal throws a lever, and one bolt will fire across, prove that the track is in the right place, the right height and level, so safe for trains to run. We also replaced all the navigation lights. So in this picture, these rather dim orange lights and the red lights on the end have all been replaced with modern equivalents, which I think are now visible from 6 miles away, as per the standard, the marine standard.
62, can't you?
You can see them from the bridge up there. Yeah, and we've dialed them down as low as we can. We also, at one point, as part of the original scope, we were asked to remove, they're only just visible in this picture, but just at the end, there's 3 little white dots you can see there, which are like floodlights on the end of the bridge, overhanging the end of the main jetty. We were asked to remove them by the Humber pilots and the harbour master. So we did. And we put the bridge, all this stuff into use, and they came out and said, we can't see the bridge anymore. Can you put them back, please? And they sent us a video. But first of all, what do you mean? It's massive. How can you miss that? So they sent us a video that one of the pilots took coming down the river, and it's amazing. You cannot see the bridge until you're right on top of it. And when the boats only just fit through the channels, some of them are about a metre either side clearance, it's very tight. So if they're not sure where they're going and they've passed the point of no return, it's either get it down the channel or smash something. So we had to go back and put some extra lights back up, which was fun. Walkway lighting, the bridge deck and the jetties, so you can see the lights now. It's all very brightly lit. Before, again, it was just the odd, rather tired old orange bulkhead lamp of which you couldn't see where you were going. So all new lighting in the handrails all the way up, the access to the track, where you would then walk along to the bridge, and all along on the bridge deck. Also, as well, which can't be seen here, but down the forefoot. So on the, I'm going to say the downline. I'll probably get it wrong. It's the downline. Yes. On the downline, there's now LED lighting every metre at track level, because that's the walkway on and off the bridge from either end. I think there's only 1 or 2 people use it from the far end, the west side, but with lighting from the full length of the bridge. And also, part and parcel of what we're doing was decommissioning the redundant equipment. So everything that was taken out, the jacks, the rams, some of the stuff in the engine room, to decommission it, leave it in a safe state, and again, as part of the heritage requirements, preserve it for future generations to see it if they ever get a chance to go on the bridge. So, some of the challenges we had. The biggest challenge, the grade 2 listed status of the bridge. So the original plans, when they were drawn up, and as was mentioned in the video, it was all going to be one push button. We were going to take out all of the original turning engines, replace them with modern hydroelectric power packs, put them straight onto what is gearbox, and do away with all the old stuff, put on the new stuff, and make it modern, fantastic new piece of kit. And when the original designs were done, that was the way we went on. And then, unfortunately for us, we didn't get the feedback from Mr. Building Concept until after the original designs had been done. So they came in quite late in the day and basically meant a complete redesign of the job, which was completed in about 4.5 months, possibly less. It was a very, instead of having 18 months prep work before the blockade, we had 4.5 months on site because of the extra redesign work we had to do. So we had to basically retain as much as possible of the original equipment, hence refurbing the engines, using the original signaling levers, using the original gearboxes, and save as much as we possibly could. One of the issues we had, access to the engine room. So the engine room is in the middle of the bridge. It's at the same height as the deck, and around the edge of the engine room are the big cogs that actually do the final drive. So to get into it, you've got to go underneath, which is basically a ladder, 8-foot passageway, and another ladder up into the floor of the engine room. That goes under the high tide level, so it's supposed to be a watertight container, bathtub as it's commonly known. It wasn't watertight. It wasn't watertight at all. We had big holes in it all over the place. It had been patched up numerous times and always leaked. So a lot of the work, it was filling up with silt. It was a danger to health and safety. And in the end, they actually stopped anybody using it. They actually condemned it, and we couldn't go in. The thought was there's another access in the track. So in the forefoot of the upline, there's access hatches where they used to drop coal in for the old steam engines, which used to be in there. And it was finding out the practicalities of using them for access for maintenance, going in and doing whatever they need to do, refilling diesel engines and stuff. It couldn't be done. So there's another project ongoing, which is put up at the minute. The temporary scaffold is still there, but they're on with building the new bathtub, new structure access. So it's a safe, dry way in and out of the engine room. Delivery materials of plant. Obviously, it's in the middle of a river. It's not the normal thing where you can just rock up with a forklift truck and drop it off. So there's specialist barges that have been used to bring everything in via boat and then craned on and off the bridge. So that's all got to be coordinated with the harbour master, with the river traffic, with the railway as well, because the bridge has to be open for certain, well, let the boats through, and certain activities. Some of the lifting couldn't be done with the bridge in closed position. How we got the power from the shore to the swing span. So that was where the IGUS chain came in. Again, it's how you could move, 600 or 700 psi running out now, or something like that, the oil. 700 psi oil, how you can move that from a fixed to a movable structure reliably, safely, and obviously power for all the lights and everything else. So they came with the IGUS solution, which is absolutely fantastic and allows it to bridge rotate in both directions.
They use that system itself in various other bridges, so it's a proven system.
Yeah. The fact that we had to refurbish the vintage engines, and I say Rob will give us a lot more details on that, because when you saw the state of some of them, and a lot of the issues we've had is pigeons. Pigeons love it in there, and we had to take the panels off the side to get in and do some of the work. We've still got the panels to put back on. There was supposed to be a project doing that, but it's been dealt with now. But pigeons make an absolute mess of the place, and what they leave behind, apart from dead pigeons, the mess that they leave is very corrosive. It can damage all the newly refurbished equipment, seals, cylinders, stuff like that. There's some pictures of it, the state it was in, and the state it's in now, even after it's been had 2-3 deep cleans. It's terrible. So, and then training. One of the other challenges we've had is people who getting the operators of the bridge used to the new system, nuances of the new system, what to do when things don't go to plan. Because some of these people working on the bridge, they've been there for many, many years. They're very used to what they do. Probably don't do much during the day. So when they swing it, it's just second nature, just pull the levers, whatever, and off it goes. Now there's a prescribed set of, it's not that different to what they used to do, but we've had a fair few hiccups where they've pulled things in the wrong order or too quickly or whatever, and the bridge stops. The safety system says, no, I can't do it. You've got to go back to a certain point, and there's been many call-outs for Rob and to the Rob, and so you're having to go out and show these people how it works again. But we're getting there. I don't think we've had any issues for 2 or 3 weeks now, at least. And the last one wasn't an operator error anyway, so it was so yeah, there's been many, many challenges, but we're getting through them. So where are we at the minute? At the minute, the majority of the works are complete. So engine number 2, which is the engine that had been out of use for 20 years, refurbished, is in and has been solely operating the bridge for the last 4 weeks. All the stuff on the ends of the bridges was done during the blockade. last June, where we had 30 days with the railway closed, because some of the works couldn't be done with the bridge in the closed position. So we had to have the bridge swung for long periods of time. So that was all the jacks, all the rams, all the pipe work was all done during the blockade last June. So we've had a proving period for the engine, because engine number one, engine number one is is still in there at the minute, and that was a known backup. So if we left 28-day proving period. So if there was any issues, we've got a known backup we could switch back to, and we wouldn't be leaving the bridge out of use. So that proving period ends this weekend or tomorrow. So start on Monday, we're stripping out engine number one and doing the renewal on that. Engine number one will be taken out, lifted out on a week on Saturday, which we've got that possession confirmed now, Rob. I don't know if you saw earlier today. And then that'll be taken down to Ipswich for refurbishment, and will be brought back to site March next year, and then rebuilt, commissioned over a couple of months, with the intention of being all done and dusted by May next year. And I think that's you, Rob. So of the engineering. So somebody who actually knows what they're talking about now.
Good evening, all. I've selected a few of the problems, obviously. I'm not going to touch on the bridge end equipment, because it's been replaced by standard jacks, and it's probably not too interesting. So I've tried to select a flavour of the problems that we came across. So the first one is the gearboxes that you could see. But that's the best picture we've got of it. You can't actually get a photograph like that from the inside. But at 160 years old, the wear on them is massive. There would have been very, very tight gears originally. But the amount of backlash now, you're talking at the end of the bridge, several metres, which gives us a problem in controlling it, which I'll probably come on to later. But the existing engines that were designed, that the braking mechanism was to slam them into reverse. And even if they go into neutral, they effectively, the engines lock up, and it's acting as a slow brake. So what was happening when we got to the bridge was that because of all this backlash, and there is 1, 2, 3, 4 interfaces of gears, as the operator opens the bridge, it's very, very smooth while it's accelerating, and then it puts it into a neutral gear. The engines lock up. The gears is horrible. They crashed across, absolutely horrible. And then at the end, they do a bit of reverse, then it stops too early, they throw it into forward to go on a bit. And the crashing of those gearboxes, you wondered how they survived. Anyway, we did some non-destructive testing on them, and we didn't find one crack, not on one tooth. It was unbelievable. Couldn't believe it. But it's a process which is just getting worse and worse. Once you start with movement, you're just ever going to increase and increase and propagate it. So John alluded to it earlier. The original scheme design, before the planners stopped it, was actually to put a new hydraulic motor direct onto one of the shafts on the gearbox and just drive that modern hydraulic motor. From a new HPU, you'd get ultimate control, you'd speed it up, you'd slow it down and take all that backlash out. But the planners came along and insisted that we had to maintain the existing engines. So the first scratching of the head with that one was marrying up a modern power pack to a piston engine, which its absorption of oil is very, very, very lumpy. The oil flow. I've got a graph of it in a minute. I've jumped on a little bit. But if you imagine one piston, the oil flow through the piston is it's like a sine wave. If you put 3 on top of each other, you lose that fluidness of the smooth shape of it. And if then you truncate the ends of each sine wave because the valve shuts, you get a very erratic curve. Now, the old accumulator that we saw that was driving the bridge originally, that just gave oil when it was needed. Pressure was always there, got 60 ton on top of it, throwing down. It just took the oil, and when it didn't want the oil, it stopped. A modern day hydraulic pump doesn't like giving out. You can get them that change the flow, but they want to control what flow they give. They don't like it when the item that they're driving wants, you know, large percentage differences in flow over split seconds. Anyway, we got there. We had numerous conversations with the manufacturers of these pumps. And we were never quite comfortable. You couldn't be. Nobody would guarantee it. But we moved forward and we got it working. Just let me check what I've lost there. Yeah, sorry, let's move on. So I think I jumped forward onto that one. Yeah. That was the graph, the approximated graph we were trying to get a hydraulic pump to marry up to. We actually then subsequently found it was slightly worse than that, because we never realised until we actually got the engine out that the pistons weren't operating at 120 degrees apart. They looked it, and they still look like it, but they're not.
You can watch video.
And the original design does show them at 120, but I think over the course of time, somebody's made a new crank and adjusted it, and you've got two of them at about 90 degrees. So that's made that even more erratic. I think they had problems getting it to start sometimes. They were down on about, when they changed that accumulator, the new accumulator was only at 600 PSI from 700 PSI. So they wiped about 15% of the power out of it. So at some point they put, well, we've done either. They either put a new crank in or the original drawings weren't correct, or there were original draft drawings that have just been, we've only got one drawing of the engines, and it's come out the Institution of Mechanical Engineers report from 1868. With regards to the engine, we knew it'd be something like a steam engine. The valves on it that we'll show you shortly, they had to be something like a steam engine because it followed that era. But it was a lot of back engineering. We took the engine out, took it to pieces, we stripped it, and very much worked out how it worked. The pieces missing. There was pieces that have been adapted over the various years. Anyway, we just got to the point where we knew what we wanted to do. But the challenge was then doing the actual refurbishment. And the other issue we had was the control. We wanted to control the bridge to stop all this backlash in the gears and protect the gear train. Because if we shatter one of those gearboxes, you're not going to replace them. It's the end of the bridge. The gearboxes were put in before the bridge deck was put on. They're that big. They're not going to come out. You're not going to be able to replace them. If you smashed one gear, you could probably make a new one in parts and put it in. But if you shatter the actual structure of the gearbox, then you've got a big problem on your hands. So what I wanted to do is control the engines. So if you were going to do a simple graph of the speed of the engine, it would accelerate slowly, hold a constant speed, and then deaccelerate very slowly, rather than this very erratic graph that we've got at the minute of power and brake, power and brake. So we decided we wanted to control the flow coming out of the engine rather than the flow going into the engine. We were concerned because of the mass of the bridge and the inertia of it, that when we were braking it, when it was in braking, it would be hunting for oil and would cause cavitation. And the pump manufacturers weren't going to warrant that at all. So we decided we'd control it on the outlet of the control valves. So here we've got the 3 green at the back of the timing valves that let the oil in and out of the pistons. And originally they just discharged virtually to atmospheric pressure, just above. They just discharged into that engine bed and just away. Well, originally just went away to a tank and then it got pumped back to the accumulator. So you've got 1 or 2 meters head of pressure on it, next to nothing. But because we wanted to control the speed of the engines on the outflow, when the engines are stopped, you're subjecting the outlet to full working pressure, 700 psi that we now operate, which they weren't doing. And when we went looking at the existing pipework in that engine bed, it wasn't a pipework, it was a great big void it went through. And if you do your quick calculations of pressure times area, would have probably blown the engine bed apart, would have cracked it. So the solution to that was actually to we left the pistons, the cylinders exactly where they are, level-wise, which we have to do because they operate off the crank. But we raised all of the valve work, we raised them by about 5 inches, which was just sufficient to get a new outlet pipe on the bottom that we could put in at the correct working pressure. And what facilitated doing that, that's an actual picture of the, at the bottom there, that's an actual picture of the connecting rod from the cam on the cylinder back to the shuttle in the timing valve. And we just simply reversed that through 180 degrees. And that gave us the 5 inches lift, but we haven't changed any of the key dimensions of the engine. The valve just works the same. As those cylinders rock, this just moves backwards and forwards.
It just moves it. So reverse is now forward and forward is reverse effectively.
Yeah, but we can change that in electrics. So that sounds easy, which it is. It's just a lot more machining. And then you come on to the problems we had with a lot of the machine work. I've just picked a selection here of the problems we have when you start machining. That's a blow up of one of those valves. Didn't look like that to start with. And the first thing is nothing. Even those 3 valves, they're entirely different. Not entirely different, but different enough to make a big difference. Dimensional difference, don't know. I think Jack made one, Harry made the other, and Bert made the other, and they all had their own tools because they're all different. The threads are different, the nuts are different. They look the same, and even sometimes to a tape measure the same, but put a micrometer on them, they're a million miles out. That gave us a problem because we couldn't just go and machine them all to a similar size, over the machine them. Because at the end of the day, the pressure vessels, and there wasn't a lot of meat left on them. We always had to be careful about how much we were taking off.
All the maintenance services were damaged.
Yeah, there's 3 housings, 1, 2, 3, the green bits on there. The maintenance services where they came together, they were all damaged, and historically they've been taken apart, and sealant and all sorts have been put in there to seal them up. They were all leaking, which we can't accept leakages because now we're over a river and we're out of the 1950s era. So he needs to get seals in them. So you can sort of see on that diagram, we've inserted these sealing plates. You can see it there in the bottom diagram. So we machined out each of the housings, each face of the housings, just to the depth of I think it was something like a 5mm thick sealing plate, which is just enough to get a double O-ring on either side that you can see there. But the problem when you're machining is, you think, yeah, I'll take that down, whatever, 2mm, and I'll just. When you get to that surface, it can be absolutely unsatisfactory because of the porosity of that existing material. You know, and you end up going another, whatever, 10,000s, 15,000, whatever, to get down to a proper surface, which means you have to be very, very careful which order you do everything in. You can't draw up all those items and then get them all made, because it wouldn't come together at the end. Because when you do the first one, you change its dimensions, and you've got to go back to your drawings, change all your drawings, so the next item fits it, and the next item fits that, and the next item fits that. So on all of the three timing valves on the main engine, and that's a drawing of one of them, unfortunately, we've ended up with no similar pieces identical.
There's no common spares.
No, there's no common spares. You can make them. We've got all the drawings, all the dimensions, but you would have to make them.
They just want final machine work. So there's these blocks from various ladder wear plates in there we've made extra.
Yeah, we've made extra and left them oversized, so you just machine them down in the future, which wouldn't take the longest time. You know, but all the threads, you know, that thread, and that thread, they're all different across the valves. I don't know whether they've been swapped over the years. I doubt it. I just think probably back in the 1860s, the machinists probably made their own tools, and they just made one item fit another. You get it on the cylinders, you know, when they go into the bores. They always made one thing fit another. You can't change anything.
Yeah, they just cut it on his lathe.
Yeah. Okay, where have we got to porosity? There's very little on there that is new. The main castings we've managed to save. We were concerned about how much meat we're taking out of them, but we've got there. These rods we've saved. The yokes at the end we've saved. We have the shuttle valves we've saved. The ladder racks we've made new, but they are at the end of the day just lumps of phosphor bronze, and the existing ones were well worn. The new part in them that you can't see from the outside is those sealing plates, and they've got rubber seals. They've gone together, and they don't leak. They work, so we're happy, and they take the pressure. Another little problem we came across. Obviously, we're now sealing these engines up absolutely tight with modern day seals. They did all run on gland seals. And if you look at the existing engine that's running, every time it gets to the end of a stroke, you see oil ooze out of the glands. And that's a function of the timing valves. The timing valve shut slightly before the end of the piston stroke, but the piston's still going out. So you effectively close your valve and then move your piston, and you get a big pressure spike. And the old seals used to just let it relieve a little bit. The modern seals wouldn't let it relieve. They'd probably very quickly get damaged by that pressure spike. And the other thing is, don't forget that one piston's driving while the other pistons are being driven, and that pressure spike would actually be detracting from the power of the engine. So that's what, you know, I've got a little accumulator on the top four. Just set at the working pressure, and it just gives you that. I can't remember the volume now. It's not that great.
Right, force. CC's is
It-
max
yeah.
in it, yeah.
Yeah, we calculated exactly when the valves were going to shut, added a little bit on and put them in, and it just gives that little bit of a spring in the whole system. Not quite to planning, but it is an item that you can take off. You can do it, take the plan, right, we'll take that off, but you can't use your engine.
But it's all reversible.
It's all reversible, yeah, because when the planners originally came to us and said, you've got to refurbish the engine, they wouldn't let us do anything without telling them what we were going to do. And that's very, very hard to know every last little thing you want to do when you haven't even started. So there's little things like that that we didn't say to the planners we're going to put accumulators on. But there was an existing hole there. We've put it on where the no bleed valve was. So, hey, if they ever come along, we'll just say, all right, we'll take it off, but you can't use your engine, please yourself. You know, it's not a detriment to the old engine. Same with everything. When we've raised the engine, we hadn't realised the engine bed had a big void in it. A pipe goes in one side and a pipe came out the other side, and we just presumed it was a void with a pipe in it that we could replace, but it wasn't. It was an actual void in the casting that had gone into. So when we've raised the valves on the engine bed by 5 inches, that's not quite in the planning, but it's all reversible if it came to it. You could take them out, you wouldn't be able to use your engine. But that's why you have your discussion with the planners, which really do you want? Do you want an engine that's 95% original and still working?
The pistons were shot as well, weren't they? They needed machining down.
Yeah, we've saved the pistons, the rods. We've saved all the ends here. The ends, they're original, remachined those. The pistons, we were machined down. We ended up machining them down a lot because there's quite a lot of surface there. We had a lot of problems with porosity on that before we got down to a surface that was good enough to build up. So they all ended up different diameters, and then they all had to be built back up to the diameter we needed.
There were evidence that they had problems before, hadn't they?
Yeah, they've been dropped and hit with hammers, the chunks in them and all sorts. But we did manage to save them. I didn't quite know how far to go today because there is hundreds of issues. The bridge end was a different story. That's like a last job now. The jacks at the end. The jacks were always going to work. It was understanding the twist of the bridge. The scissor lifts that John referred to earlier, or knuckle joints that we'd probably call them better. They do lift in a scissor sort of arrangement, which has to be symmetrical. You know, if you've got a scissor jack, it's got to go up so one side opens the same as the other. If you keep the pin in the middle of the cross geometry, you can't do anything else. But somewhere along the lines, the height from the lifting point down to the bearing surface has been changed. It couldn't lift symmetrical, which means the pin had to move across. So the actual reason it wasn't lifting is that most of the energy of the lift was actually going into trying to move the whole of that lifting equipment across. And it actually bent some of the steelwork, big meaty steelwork. A little power was left to actually lift it. So I always felt that was a bit of a shame because I reckon I could have refurbed them.
Good stuff. Thanks, guys. Any questions in the room? Any questions online?
Thank you very much. How does the performance you expect to get from the work you've done in terms of reliability and availability of the bridge compare with what you'd have achieved had it been the new option that you originally were thinking of?
The gut I actually think they'll be similar.
Okay.
And the reason I say that is, we're driving it with a modern hydraulic power pack, and that hasn't changed. It would have always been one similar,
Yep.
slightly different pump, you know, different flow rates, whatever. And you'd have had a new hydraulic motor bolted onto the gearbox. The reliability they have. Those, all that kit in there with those engines and the valves, when they're refurbed now, they'll be good for years. They don't do that much work, but it's massive stuff.
Am I right? It's only something like 30 cycles of the engine, of the turning engine for a full
Yeah, but
the bridge, so it's not.
They originally did 18. The engine did 18 revs to open the bridge. But the gearbox has got a low and high box on it. You can actually lower it. We've actually put it into the low gearbox because to eliminate the issue of there being enough power to set it off. Quite often the signal has had to go into reverse and rock the bridge to get it going. Well, quite hard to write a program on your control system to get it to do that. So we plumped for dropping it into the lower gear, which is the ratio of 2 difference. So now we've got a lot more power, but it does go slower than it used to do. But whereas the signalers manually used to go left, right, and trying to line it up, we're a bit like a tortoise and a hare. We go slower, but we finish.
Yeah.
Oh, so we are slightly longer, but that wasn't your question. I think your question was on reliability.
Yeah.
If there's going to be, I don't think those engines will fail because you've got brand new Victorian engineering and the last one. And I think where the problems will come, and they're only minor, and it's a maintenance issue that needs to be done before it happens, is it's swinging back and lining up. Because there's that much backlash, when you actually come to line it up, we've got to slow the bridge down and then actually drive it into position. So you're actually pushing where the teeth are and you slow it right down to as slow as you can go. Drive it into position, stop. And you've then got to be within about this 4 inches either way so that no tapered nose bolts can line it up. If you slow it down too fast and you're on the other side of your gears, all the gears are flopped over to the other sides, you know, you'll be 2 meters out. If you didn't oil your wheels of the bridge, the rotating wheels, and then you went and oiled them, you'll upset the balance. If you keep the status quo, you'll be fine. There is a jog element on the control system. If it doesn't line up, you can just jog it left or right into position, but that takes time. You don't want to be there. So it'll come out of tune, might be the way of putting it, but not fundamentally right.
Good stuff.
Yeah.
A few questions appearing online as well. How many times a day or week does the bridge open?
Very variable. We've gone through several months without a ship coming up to docks, and now they're coming a few a week. But the proving period we've just done with that engine, we've opened it twice a day for 28 days.
Plus any
Plus ships.
any movements for ships as well. So yeah,
It is very variable through the months.
Mr. Valentine, I'll take the question on, can we arrange a PWI site visit to the bridge? And I'll think about that one separately. Someone, Peter Woodbridge, I'm interested to know how the project managed to get its funding. What does the business case look like in terms of spending £10 million on this route?
good question.
I'll let John have a go and then I'll have a go as well.
It was funded fully through the EMP renewals budget. It's basically, if that bridge doesn't work, we close the line between Doncaster and Gilberdike. And you've got who uses it, Hull Trains, LNEI use it, multiple passenger, other passenger services, freight as well. So the costs of not having that bridge there and everything having to run via Selby, I think would be the other way to get around. Yeah. So run that way around.
I guess the capacity issues on that other elements of that other route as well would have
With
for the men.
with another swing bridge.
With another swing
Yes.
bridge.
Yeah,
Well, that,
so basically, yeah, like we said, it was running on one engine. If that engine had failed, that's the line shot.
Is
well,
it, sorry, Ben, the two engines, is it one or the other, or do they share the work?
No, it's one or the other. Yeah,
It's
everything's
full redundancy.
full redundancy, yeah.
Okay.
they will be.
Well, it's your kit as well. So there was two engines which were reversed. The two vertical pumps, which were in the original video that we showed. One of them at either side. There's a, I think, 1920s diesel engine next to each of those, which does the charging of the vertical pump that puts the oil back in. It's two gearboxes.
The common failure point would have been the accumulator,
Right.
which would have happened when the seals need changing. You'd only got one power plant effectively. The HPUs we put in, we've got dual, we separate, it's one HPU, but it's side A and B. One side for the bridge end equipment and one side for the engines. They've both got two pumps. With the jacks, we use both pumps to lift the jacks, but if one pump goes down, it just takes twice as long to lift them. With the engines, we just run on one pump and alternator. So we've actually a bit better off now because we've got two power packs where we only have one accumulator.
Your question, your observation leads on to my next question, which is, okay, how much transferable learning is there from what we've done at Goole to what might be needed at Selby and Hull, I guess, and other swing bridges in
Hull
future?
Hull interests me particularly because it's 5 minutes from my house. Hull swing bridge. So that'd be brilliant for site.
The both base, a totally different beast, isn't it?
It's a totally different beast, but I think there's a lot of learning that we can have, particularly from the heritage side of it, and the making sure that we've got all that done and dusted up front and fully agreed.
Is that why you ended up finding out so late in the day of the heritage system? Were they not involved early enough?
As far as I understand it, I mean, I don't want to slurp your shoulder it, but I'll come on to the project January last year. But as far as I understand it, they had been engaged initially. There'd been some feedback, and we'd gone ahead on the feedback rather than actually getting the signed documents in. Go ahead. When the signed document came back, it was different to what we were envisioning, which necessitated basically the full redesign of the vast majority of the work.
The lesson I'd take from it, because it was a construction only really job. There's bits of design in it and bits of details there, but it was handed over as a build job. But when we've had to do the redesign of it, with respect to the planners, there's a very useful group of people in the Victorian Society, and they're engineers, and you can speak to them. Now, you'll never pull the wool over the eyes because they'll know more about that bridge than you do when you first set off there. But they're reasonable people, and when you can't do something, they'll appreciate that you can't do it, and they'll understand you can't do it, and they'll pretty much get to a best endeavours point quite readily with you. Whereas the planners aren't engineers. But the planners will always go to the Victorian Society and consultancy.
So I think that's the bottleneck. But the fact that a relatively small planning authority end up having to seek specialist support that is limited in its quantity. So therefore the feedback loop is so much longer, more protracted.
And the planners are normally dealing with, around here, there's a lot of grade 2 listed buildings. They're into facades. And I think one of the problems with them was they were thinking about the facade of the bridge.
Sure.
What it looked like from the outside, and it had been changed so much over the years with various refurbs. I think that's where the interest hadn't come from. And I think maybe our predecessors thought they might not quite realise the engines were in there, but they did.
I think, that initial consultation and making sure that we've got all parties bought in, and it's not just the external, but the internal as well. So the guys that are going to be out there day to day working on it and making things better for them. So it was quite a late change in the project, the moving the diesel engine everything to the shore, but the PSP on the shore. We could have designed that from the off, and it would have been much more straightforward. I mean, it's done. It's a great job.
The delays to the job are because of having to redesign it, and then it's been done in a bit of a a backward fashion. It wouldn't be the choice of your way of building it. Had you come to the construction phase with all that ahead of you, I don't think your pricing program would have been much different. And then you go back to the question you asked earlier about the quality and the reliability. That wouldn't have been too much different as well. You've got a few annoyances in there. The fact that we've got to still use existing levers upstairs to operate the bridge. I mean, they used to operate hydraulic valves and they don't now. They just operate a damn switch that we've put on. It's a lot easier to have a switch on that.
There's literally a 3 foot long lever that they pull that then operates a little switch underneath it. that then starts to move.
But, you know, in time you can see that that'll get superseded and what have you. But the fundamental engineering, I think you've got to try and work with it.
Sure.
Eliminate your risks. The accumulator was an environmental risk waiting to happen. Your health and safety hazards of going down it to fix it were getting so it was nearly obsolete. It went down into the riverbed. You couldn't get at it. You needed to go back to the days when you put kids up chimneys to do it. So there's certain things you had to get rid of. But when you're under pressure from the planners, when you look back on it now, although it was a massive headache about using the existing engines, when you're looking back at it after you've done it, you think, well, that'd be about right, you know.
You achieved a fantastic.
And you could have probably done it for a similar amount of money and in the similar time scale had you set out in that vein at the start.
We had the same issue with the nose bolts, didn't we? The access to it were unrealistic, wasn't it?
Yeah, I think there's is it the old
The old
thing that
chain.
used to go, the old chain that
Right.
used to go straight up from the bridge, straight down the middle. There was only one lad in maintenance could ever get in there because the access hatch was so small.
So the nose bolts at the end were activated by a mechanical chain that was connected to a lever that went down through the middle of the bridge and then out to the nose bolts.
It's not this big.
Yeah.
Oh,
Yeah.
You employ somebody small to be able to do it.
You had to get in there twice a year because in the summer, the whole length of that chain and cable
Change length.
changed length.
Yep.
And they had to go in and remove one link, so the nose bolt pulled out to the bridge. But
Any
no,
other questions? Questions about?
Yeah, I was going to ask you about the accumulator, because you mentioned it just then. I mean, how much do the planners resist you getting rid of that? Because they wanted to keep all the other stuff.
saying we get rid of it, we're not. We're just decommissioning it.
Okay.
It's all been all the accumulator, the 3-throw pumps that you saw in the original video that pump it back up, and the diesel engine that they're 1930s vintage. They class them as that. All that is just getting decommissioned and left in place.
Just been mothballed.
Mothballed. It's a shame because nobody's going to ever see it. It's like that statement somebody put up at the start. It's the most in the museum going. So no, they won't let us get rid of it. The only thing reluctantly they've let us get rid of is the knuckle joints. Originally we wanted to keep one, but no museum was interested in it. Really big, really heavy. You know.
Was part of the scope to include the rotation elements as well? Is that in your scope of work or not really? It was.
So the rotation, the turning engines, that was always part, that was the main thrust of the job, was anything with the hydraulics, which was the turning of the bridge and then the jacks and the pistons at the end of the bridge to lift and.
So those engines we've been referring to, the gearboxes, they actually turn the bridge.
So
There's a video of it.
compliment from Andy Batters, who says, "Thanks guys, an amazing project. You should be very proud and look back on it as a great opportunity for applying first principles engineering." So I absolutely agree. Yeah.
Do you want me to just put that we've got a quick video of it in operation.
Go on, let's show that.
If you want me to
We'll finish there.
put that on the screen, I'll try not to put any adverts on. Right, this, fingers crossed, this one should be just.
It moves a lot smoother than this.
Really smooth on there.
Getting smoother as the Wi-Fi is getting used to.
eliminated the engine rev. One half of it where it's slightly faster than the other half because of the crank not 120 all the way around. It's just more noticeable when you slow the engine down, you can actually see it. So we just had to move the gear knob a little bit so when you come up the top, it's the lowest point. You can see the wheels at the back there, the bridge is rotating on.
How long does a bridge swing take?
Being fully locked in the
Yeah.
other position.
Yeah. Go up the door.
Just over 3 minutes.
It does say, if this wasn't before we got the job, it wasn't that bad. It does say in that mechanical institution report from 1868 or whenever it was, that they used to do it in 50 seconds.
Which mechanical sympathy?
Well, no, and I'm not sure they quite had the power to do that. I don't.
Yeah,
It does allude to included the jacks as well. I just can't believe that. I think that'll be some going for the bridge swing.
It would, because we've run that engine, or the refurb engine, at various pressures and speed and flow, and there is an optimum speed for it.
Yep.
And it's about there where it is.
Okay. Guys, thank you very much. If we can show our really is a work of art, and feel quite privileged. I feel privileged having been there and been in that engine room and seen how it operates. So not quite seen it operate, because you wouldn't want to be in there when it was operating. But, yeah, impressive stuff. Thanks to those online for obeying the rules around staying invisible. Hopefully it's been useful for you. Thanks to everyone in the room for coming along. Quick reminder, next time, NEREF next week, next Wednesday, British Steel visit on the 15th of October. For anyone welcome. And back here in 4 weeks' time for the National Railway Museum meeting, planning and delivering a new museum. So we'll see everyone then.
Thank you.
Thank you.
Thank you. Really appreciate it, Rob. Thank you.
Yeah, thank you. Well, the great thing is 90% of it. I'll have to find other ways to get you to deliver the same goods.
Well, just if you do that, but
the business we've done absolutely so far. It's not amazing. Well, we're not staying. So the added twist is you've got TV things for everybody to be able to get out into the bridge. That's the challenge. Which I think I'm absolutely because we're not doing it as Nevertheless, we're doing it as a separate institution. I'd have to sign up to that as. No, it's not sticking blank. Which is fine.
I mean, it's not when it is track size, but it's
right.
It's just walking down the track forever.
The other challenge I have is if I read the PWI, the IMEC here go ballistic at me and say, how can you manage to get people out on the